Okay, in this problem, we have nitrogen gas in a piston cylinder assembly that undergoes a compression from this initial state to a final state with a pressure of 2 megapascals. And it says that the relationship between the pressure and the volume during this process is PV to the 1.35 remains constant, so we have this polytropic process. Okay, so for the nitrogen, go ahead and determine the volume at the second state, and then the work during the process. So we'll start by finding the volume at the second state, which is pretty easy. We just know that this relationship is constant here. So that basically means that P1 V1 to the 1.35 equals P2 V2 to the 1.35. And of course, I know everything here. I know P1, I know V1, and I know P2. The only thing I don't know is V2, so that V2 becomes basically P1 over P2 divided by that, and then I get V1 to the 1.35, and of course I'm going to take this to the inverse power 1.35, like so. So then plugging in P1, P2, V1, I can then find V2, and I find V2 is equal to a half cubic meter. Okay, so again, that one's pretty simple. Again, knowing that this is constant, I just have the initial state equal the final state and solve for V2 algebraically. Pretty straightforward. Okay, now in order to find the work, okay, I'm going to use my work equation, which of course is the integral of P dV. Okay, now I know the relationship right here, PV to the 1.35 is constant. Okay, so what I'm going to do is I'm going to solve for P here and plug it in down here so I get everything in terms of the volume so that I can do the integral, because right now I've got a P that I'm trying to integrate with respect to the volume. Okay, so basically I'm going to plug in for P that whatever the constant is, which we'll get to in just a second, divided by V to the 1.35 dV. Okay. So again, all I did was I plugged in what I know about P into here. Now, of course, constants can come outside the integral, and that constant is going to be P1 V1 to the 1.35, right? Or I could have done P2 V2, but they gave me P1 and V1, so I'll use that, to the integral of the volume to the negative 1.35 dV. Okay. So then this integral, again, I have my constants. I can plug those values in as I need to, P1 V1 to the 1.35, and then this integral then becomes negative V to the 0.35 divided by 0.35. And of course I'm going to integrate this from V1 up to V2, which I know I have V1 and I have V2. Okay. So now it's just plugging in the values. Okay. And once I set up this integral, again, plugging in what I have for V, pulling the constant out, doing the integral of V to the negative 1.35, I get this. Plugging in all my values, I get work equals negative 1283 kilojoules.